Hello students, today we are going to study non-destructive test of concrete. Non-destructive test of concrete is a method to obtain the compressive strength and other properties of concrete from the existing structures. This test provides immediate results and actual strength and properties of concrete structure. The standard method of evaluating the quality of concrete in buildings or structures is to test specimen cast simultaneously for compressive, flexural and tensile strengths. The main disadvantages are that results are not obtained immediately, that concrete in specimens may differ from that in the actual structure as a result of different curing and compaction conditions, and that strength properties of a concrete specimen depends on its size and shape. Now, the methods of non-destructive testing of concrete. Following are the different methods of non-destructive test on concrete. The first one is penetration test, another one is rebound hammer test, the next one is pullout test method, the next one is ultrasonic pulse velocity method, and the last one is radioactive method. Now we will start with the penetration test on concrete. The Windsor probe is generally considered to be the best means of testing penetration. Equipment consists of a powder actuated gun or driver, hardened alloy probes, loaded cartridges, a depth gauge for measuring penetration of probes and other related equipment. A probe diameter 0.25 inches and length 3.125 inches is driven into the concrete by means of a precision powder charge. Depth of penetration provides an indication of the compressive strength of the concrete. Although calibration charts are provided by the manufacturer, the instrument should be calibrated for type of concrete and type and size of aggregate used. Now, these are the pictures of penetration equipments like this. Now, the benefits and limitation. The probe test produces quite variable results and should not be expected to give accurate values of concrete strength. It has, however, the potential for providing a quick means of checking quality and maturity of in situ concrete. It also provides a means of assessing strength development with curing. The test is essentially non-destructive since concrete and structural members can be tested in situ with only minor patching of holes on exposed faces. Now the next method is the rebound hammer method. The rebound hammer is a surface hardness tester for which an empirical correlation has been established between strength and the rebound number. The only known instrument to make use of the rebound principle for concrete testing is the Schmidt hammer, which weighs about 1.8 kg and is suitable for both laboratory and field work. It consists of a spring controlled hammer mass that slides on a plunger within a tubular housing. The hammer is forced against the surface of the concrete by the spring and the distance of the rebound is measured on a scale. The test surface can be horizontal, vertical or at any angle, but the instrument must be calibrated in this position. Calibration can be done with cylinders of the same cement and aggregate as will be used on the job. The cylinders are kept and firmly held in a compression machine. Several readings are taken, well disturbed and reproducible, the average representing the rebound number for the cylinder. This procedure is repeated with several cylinders, after which compressive strength are obtained. Now in this way, rebound hammer is used for the determination of compressive strength of the concrete. Now the limitation and advantages of the rebound hammer test. The Schmidt hammer provides an inexpensive, simple and quick method of obtaining an indication of concrete strength, but accuracy of plus minus 15 to plus minus 20% is possible only for specimens cast, cured and tested under conditions for which calibration curves have been established. The results are affected by factors such as smoothness of surface, size and shape of specimen, moisture condition of the concrete, type of cement and coarse aggregate, and the extent of carbonation of surface. Now the next test is the pull-out test on concrete. A pull-out test measures with a special ram the force required to pull from the concrete a specially shaped steel rod whose inlaid end has been cast into the concrete to a depth of 3 inches. The concrete is simultaneously in tension and in shear, but the force required to pull the concrete out can be related to its compressive strength. The pull-out technique can thus measure quantitatively the in situ strength of concrete when proper correlations have been made. It has been found over a wide range of strengths that pull-out strength have a coefficient of variation comparable to that of compressive strength. This is the equipment used. Now the limitations and advantages. Although pull-out tests do not measure the interior strength of mass concrete, they do give information on the maturity and development of strength of a representative part of it. Such tests have the advantage of measuring the quantitatively the strength of concrete in place. Their main disadvantage is that they have to be planned in advance and pull-out assemblies set into the formwork before the concrete is placed. The pull-out, of course, creates some minor damage. The test can be non-destructive, however, if a minimum pull-out force is applied that stops short of failure but makes certain that a minimum strength has been reached. This is information of distinct value in determining when forms can be removed safely. Now the next test is the ultrasonic pulse velocity test. At present, the ultrasonic pulse velocity method is the only one of this type that shows potential for testing concrete strength in situ. It measures the time of travel of an ultrasonic pulse passing through the concrete. The fundamental design features of all commercially available units are very similar, consisting of a pulse generator and a pulse receiver. Pulses are generated by shock exciting piezoelectric crystals with similar crystals used in the receiver. The time taken for the pulse to pass through the concrete is measured by electronic measuring circuits. Pulse velocity tests can be carried out on both laboratory sized specimens and completed concrete structures, but some factors affect measurement. There must be smooth contact with the surface under test. A coupling medium such as a thin film of oil is mandatory. It is desirable for path lengths to be at least 12 inches in order to avoid any errors introduced by heterogeneity. It must be recognized that there is an increase in pulse velocity at below freezing temperature owing to freezing of water from 5 to 30 Celsius. Pulse velocities are not temperature dependent. The presence of reinforcing steel in concrete has an appreciable effect on the pulse velocity. It is therefore desirable and often mandatory to choose pulse path that avoid the influence of reinforcing steel or to make corrections if steel is in the pulse path. Now this is the equipment and the principle used in the ultrasonic pulse velocity test. Now application and limitation of the ultrasonic pulse velocity test. The pulse velocity method is an ideal tool for establishing whether concrete is uniform. It can be used on both existing structures and those under construction. Usually, if large differences in pulse velocity are found within a structure for no apparent reason, there is strong reason to presume that defective or deteriorated concrete is presented. High pulse velocity readings are generally indicative of good quality concrete. Now the next method is the radioactive method of non-destructive testing. Radioactive methods of testing concrete can be used to detect the location of reinforcement, measure density and perhaps establish whether honeycombing has occurred in structural concrete units. Gamma radiography is increasingly accepted in England and Europe. The equipment is quite simple and running costs are small, although the initial price can be high. Concrete up to 18-inch thick can be examined without difficulty. Now this is the equipment and the principles. Now purpose of non-destructive test on concrete. A variety of non-destructive testing methods have been developed or are under development for investigating and evaluating concrete structures. These methods are aimed at estimation of strength and other properties, monitoring and assessing corrosion, measuring crack size and cover, assessing grout quality, detecting defects, and identifying relatively more vulnerable areas in concrete structures. Many of non-destructive test methods used for concrete testing have their origin to the testing of more homogeneous metallic system. These methods have a sound scientific basis, but heterogeneity of concrete makes interpretation of results somewhat difficult. There could be many parameters such as materials, mix, workmanship and environment which influences the result of measurements. Moreover, these tests measure some other properties of concrete, that is hardness, and the results are interpreted to assess a different properties of concrete, example strength, which is of primary interest. Thus, interpretation of results is very important and difficult job where generalization is not possible. As such, operators can carry out tests, but interpretation of results must be left to experts having experience and knowledge of application of such non-destructive tests. Now, more purposes of non-destructive tests are estimating the in situ compressive strength, estimating the uniformity and homogeneity, estimating the quality in relation to the standard requirement, identifying areas of lower integrity in comparison to other parts, detection of presence of cracks, voids and other imperfections, monitoring changes in the structure of the concrete which may occur with time, identification of reinforcement profile and measurement of cover, bar diameter, etc., condition of pre-stressing reinforcement steel with respect to corrosion, chloride, sulfate and alkali contents or degree of carbonation, measurement of elastic modulus, and the last one is condition of grouting in pre-stressing cable ducts. That is all about the non-destructive test. Thank you very much, students.